speed control of DC series motor. In a series motor, the field winding is connected in series with the armature. So here also we have different methods. One is flux control method, and the other is armature control. So in flux control method, we have different methods. One is field diverter. Field diverter. So here it is the series motor. We are giving the electrical input and the field winding is connected in series with the armature. So in series motor, that is flux control method, we are connecting one field diverter like this, variable rheostat across the series field winding. What is the main purpose of connecting this field diverter means in order to limit the current flowing through the series field winding. So that portion of the current will be flowing through the field diverter, which means that the amount of current flowing through the series field winding can be controlled. Thereby, we can control the speed. As I have already told you, N is proportional to EB by phi, where EB is given by V minus IA or A divided by phi. So, if the amount of current decreases through the series field winding, then the flux also decreases. So, speed above rated speed can be possible with the help of field diverter. But particularly in series motor, speeds above rated is not advisable one because it will damage the series field winding. And another one method is armature diverter. So in armature diverter, here we are connecting one variable resistance across the armature. So So the amount of current is getting divided to another path. That is, we are connecting one variable resistance across the armature, which means that the amount of current flowing through the series field winding is controlled. Thereby, in case of armature diverter method, the amount of voltage across the armature is decreased. As I have already told you, N is proportional to EB by phi, which means that V minus IA or A by phi. So if the voltage decreases, automatically speed also decreases. So with the help of this, this is the concept behind armature diverter method. And another one is tapped field control method. So here in tapped field control method, we are providing amount of tappings that can be controlled because in a series field winding, we are connecting some tappings. So the amount of windings included can be controlled. So in case of DC series motor, it will be provided with some amount of tappings. So the amount of windings included can be controlled. That is called tapped field control method. And another one is paralleling of field coils. So paralleling of field coils. Here regrouping of field coils can be achieved so that variable speed is possible. So we have different combination of connection of field coils. So these are all the series field winding, and it can be connected in different ways. So it can be connected in different ways by means of connecting So these are all different connections of coils. With the help of that, we can obtain variable speed. So with this, we have discussed about what is a DC motor, its principle of operation, and then what are all the types of motor available, DC shunt, series and compound motor, and their characteristics, different characteristics we have discussed, electrical characteristics, mechanical characteristics, that is torque versus armature current characteristics, speed versus armature current characteristics, speed torque characteristics we have discussed. And we have discussed about the applications. The applications of DC motor means mainly DC shunt motor is preferred for constant speed applications. Series motor is preferred where high starting torque is required, particularly in electric traction. That starting torque required is very much higher. At that time, DC series motor is preferred. And then we have discussed about the speed control of DC motors. We have different methods: flux control method, armature control method. And in flux control method, speeds above rated speed is possible. In armature or rheostatic control methods, speeds below rated speed is possible. Thank you.